Okay, so on this video we tackle about the length of curve, which is the application of integral. No? Consider this the Cartesian plane contains with a y-axis. Then we have the curve here in the first quadrant of the Cartesian plane. Okay, so if we assume the small rectangle or right triangle on this curve, okay, so let's get bigger the right triangle to emphasize the Pythagorean theorem. Okay, so in this case, this would be the our right triangle, no? So if we get ds here, that is stands for the length of the curve, no, or the change and the length of curve. Then here dx, then we have dy here. Okay, so if you know that the Pythagorean formulas, or that would be equal to c squared, a squared, then plus b squared. Okay, so if we write the quantity of ds squared, then it is equals to the quantity of dx squared, then plus quantity of dy squared. Okay, then if we take the quantity of 1 over dx squared, no, okay, so if we multiply both sides, no, here, so this would be the quantity of ds squared over quantity of dx squared. Okay, that would be equals to, this would be equals to 1, then plus quantity of dy squared over quantity of dx squared. Okay, so in this case, this would be equals to the quantity of dy over dx, then we have squared here. Okay, so we have ds, or quantity of ds squared, that would be equals to 1 plus the quantity of dy over dx squared. Okay, then we have the bracket, open bracket and close bracket, then we now cross multiply, so this would be multiplied by quantity of dx squared. Okay, we can now square out both sides. Okay, so this would be cancel out, so this would be ds, that would be equivalent to the square root. Okay, the square root of 1 plus quantity of dy over dx. Okay, then we have squared here, then take note quantity of dx squared, so if we square root the quantity of dx squared, it would be cancelled, so therefore it will remain dx. So now we can now apply the integral, which is to find the equivalent length of curve. Okay, so you must integrate also. So where a is here, the integral of ds, that is s, and that would be equivalent to the integral of square root of 1 plus the quantity of dy over dx, then we have squared here. Okay, then times dx. Okay, so since with respect to dx, so our x values or limit is in x, so we have x sub 1 and x sub 2. So that would be the first formulas. Then, by the way, if you change this or this into 1 over quantity of dy squared, okay, so this would be ds, or quantity of d squared, then that is equals to quantity of dx squared, then plus quantity of dy squared. Okay, so if we multiply 1 over dy squared, okay, okay, so we can now multiply both sides here and to this. So we have quantity of ds squared over quantity of dy squared. Okay, then that would be equals to the quantity of dx squared over the quantity of dy squared, then plus this would be equals to 1. So quantity of dy squared over dy squared, that is equals to 1. Then we have ds, or quantity of d squared here, that would be equals to the open bracket, or this would be equals to dx, or quantity of dx over dy. Okay, then we have squared, then plus 1, then close bracket, then cross multiply, so times dy over dx. Okay, let us now take the square root in order to cancel out the squared. Okay, both side we take the square root, so this would be the ds, then that is equals to quantity of dx over dy. Okay, then square, then plus 1. Okay, so don't forget to write the square root. So again, the same with this, no, dx. So here dy here, square root of the quantity of dy squared, so that is equals to dy. Okay, so again, let us now integrate in order to get the length of curve. So whereas here, that would be equals to the integral of quantity of dx over dy. Then we have squared here, then plus 1, or the square root of quantity of dx over dy squared plus 1. Then we have dy here. Okay, so since our change in curve, or that would be respect to the dy, so therefore our limit values is in y values. So we indicate y sub 1 and y sub 2. Okay, so for example, if you have a given again, this would be the two formulas, no. For example, no, if we had a given the equation of the curves, so which is y is equals to 4x cubed, then plus 3x squared, then plus 4x is equals to 10. Okay, from, or where x is equals to 0, to x is equals to 2. Okay, so first thing to do is we need to get the dy over dx, which is our first derivative, no. So this would be dy, that would be equals to or we put here dy over dx here. So the derivative of 4x cubed, that is 12x squared, then plus 6x, then plus 4. Okay, so let us now substitute this equivalent formula. So that is s is equals to integral, or where the limit from 0 to 2, then the square root of 1 plus 12x squared plus 6x plus 4, no? Okay, then we have squared here, then dx. Okay, so if you use our calculator to calculate the equivalent length, so that would be equals to the integral from 0 to 4, no? So we can now input the equivalent of s, or this given, no, na itong gi-formulate. Then I can, okay, so this is alpha x squared plus 6x plus 4. Okay, check lang. 12x squared, then 6x, then plus 4. Then where limit is 0 to 4. Okay. So therefore, our area here, that would be equals to 52.07. No? So where s is equals to 52.07 length, no? Okay, so that would be the final answer. So next, another is if you given, no, for example, x squared is equals to 4y plus 8. Okay, for example, like that, no? Okay, then from limit of y is equals to 0 to y is equals to 10. Okay, so for example, since our dx over dy here, so we need to take the first derivative of dy over dx. So first thing to do is we need to get the square root both side, then cancel out. Then we have x, that would be equivalent to the 4y plus 8, no? Okay, or the quantity of 4y plus 8 to the powered 1/2. Okay, so we take this derivative, so this would be dx. Okay, dx over dy. Okay, so here we have 1/2, then times the 4y plus 8, then to the powered 1/2 minus 1, that would be equals to negative 1/2. Okay, so we take the chain rule, which is the derivative of 4y plus 8, that would be equals to 4. Okay, and then where the x over dy here, that would be equals to 2. The quantity of 4y plus 8 to the power negative 1/2. Okay, so let us now apply to this equivalent value in this given formula, no? Or so that would be equals to y here, 0 to 10. Okay, so the integral of 2, or we get the open bracket, so 2 times the quantity of 4y plus 8 to the power negative 1/2. Then we have square here. Okay. Then plus 1. Okay. Then we have dy here. Okay. So let us now calculate. Okay. So if you done input, then equals okay. So by the way, we let to review, no. So 2 quantity of 4y plus 8 to the power negative 1 half. Okay, so I think that would be 0, no. So equals, so that would be equals to s, where s is equals to 10.85. Okay, so that would be the final answer. Determine the length of curve where x is equals to quantity of 2t plus 3 to the power 3 over 2, and y is equals to 3 quantity of t plus 1 squared. So from t is equals to negative 1 to t is equals to 5. Okay, so in this case, for finding the length of curve, so take note that our formula of that is that it be equals to the square root of the quantity of dx over dt. Okay, and squared, no, then plus dy over dt. Okay, then squared. Okay, so for our limit here from t sub 1 to t sub 2. Okay, so first we have the given x and y equivalent. So we need to derive this. So this is dx over dt. So that would be equals to the quantity of derivative of this, no? So which is 3 halves, then times 2t plus 3. Okay, then to the power 3 halves minus 1, that will be equals to 1 half. Then we get the chain rule. The derivative of 2t plus 3, that would be equals to 2. Okay, so therefore our dx over dt here, that would be equals to 3 or 60, no? 6 times 2t plus 3 to the power 1 half. Okay, so if you derive this given in terms of y, so y or dy over dt, that would be equals to 3 t plus 1, then the derivative of 2 or 2 minus 1, that would be equals to 1, no? Then we get chain rule, that would be equals also to 1. So over dy over dt here, that would be equals to 3 okay, or by the way, I forgot to multiply by 2 here. Okay, so we have 2. Then we have 2 times 2, that would be equals to 6. Okay, so we have t plus 1. Okay, so now we can now substitute this equivalent dx over dt and dy over dt, no? So again, the limit is -1 to 5. Then we take this square root, no? So we have 6 quantity of 2t then plus 3, then to the power 1/2, or by the way, we get this bracket, open bracket and close bracket, so we have 2 here. Then plus the equivalent of dy, that would be equals to 6 t plus 1. Okay, then we have squared here, then dt. Okay, so we're easier, that would be equals to, by using the calculator, okay, 3, then plus quantity of 6, then we have alpha x plus 1, then the power 2. Okay, so recheck quantity of 6 times quantity of x plus 1, then to the power 2, no? Squared, then square root of 6 quantity of 2x plus 3, then we have 1/2 here. Okay, so to the power 1/2, so equals, okay, so our length of curve, that would be equals to 144. Okay, unit length. Okay, so that would be the final answer. So next example, if you given r as equals to a cosine squared, then we have 1/2 of theta here. Okay, by the way, in this curve, so if the problem says that determine the length of the curve, okay, so determine the length of curve, or which is this curve, or indicate, or this type of word is cardioid, no? Of length of curve which is cardioid. Okay, so for example of this, again, so r is equals to e cosine squared, then 1/2 theta, no? So again, in this scenario, so we can now use this formula, no? S is equals to the integral of, since talking about the angle, so we need the limit from 0 to 2 pi. Okay, so that would be the square root of r squared, then plus r prime, okay, then squared d theta. Okay, so take note that our r is equals to f of theta. Okay, or r prime, that would be equals to dr over d theta. Okay, or the first derivative. Okay, so take note, we take this derivative. So dr over d theta, that would be equals to, okay, so we have a, then the derivative of cosine squared, then quantity of 1/2 theta, so that would be equals to the derivative of cosine, that would be equals to negative sine, or negative sine squared, not sine squared, but 1/2, or negative sine 1/2 theta. Then since we have squared here, so 2 minus 1, that would be equals to 1, no? So therefore we have cosine 1/2 theta here, okay, times 2. We get the chain rule, no? You have times 2 here. So to finalize our dr over d theta, okay, so this would be negative a, then sine 1/2 theta, then cosine, okay, then 1/2 theta. Okay, so take note, we have 2 here, so we can now write this 2 here. So negative 2a sine quantity of 1/2 theta times cosine 1/2 theta. Okay, so we can now substitute that. So we have from 0 to 2 pi, then the square root, so r squared here, so this would be the equivalent a, then cosine squared, and we have 1/2 here, theta, no? Then we take this squared here, then plus, we can now input this quantity of negative 2a, then sine 1/2 theta, then cosine, okay, quantity of 1/2 theta, then we take this squared here. Okay, so let us now simplify this. So you have 0 to 2 pi, then the square root, okay, quantity of e squared, then cosine to the power 4, 1/2 theta here, then plus quantity of 4 e squared, then sine squared 1/2 theta, okay, 1/2 theta, or we have squared here, okay. Okay, so this would be equals to the integral of 0 to 2 pi, then the square root, no? So we can now factor out e squared, no? So let's say a squared here, the quantity of cosine, 4, then 1/2 theta, okay, then plus 2 times sine squared, then 1/2 theta, okay, then cosine squared, then 1/2 theta. Factor out cosine, okay, cosine squared. So if you take the square root of the a squared, it would be a, no? So the integral of from 0 to 2 pi, no? Okay. So let us now factor out cosine squared. We have cosine squared 1/2 theta. Okay. Then open bracket. So we have, in this case, we have cosine squared 1/2 theta, then plus so I can review this. So again, I have the little bit I forgot to apply also the general of 1/2 theta, no? Okay, so in this case, if we derive 1/2 theta, again this would be the given, no? So if we derive this 1/2 theta, that will be equals to 1/2. So therefore we can now multiply by 1/2 here. Okay, so since when we multiply 1/2, so this would be cancel out, then this would be no more 2 here. Okay, so therefore we have cosine squared quantity of 1/2 theta, then another is sine squared. Okay, sine squared, then 1/2 theta. Okay, then we have d theta here. Don't forget, no, because s with respect to d theta. Okay, so by the way, if you think this equation, or that would be considered as the don't forget also to think the Pythagorean relation in terms of trigonometric substitution, which is cosine squared x plus sine squared x is equals to 1. Okay, so therefore we have the integral of 0 to 2 pi. Okay, then we have the square root of the cosine squared 1/2 theta here, then times 1, then d theta. Okay, so the integral from 0 to 2 pi, and we can now cancel out squared here. So we have cosine the quantity of 1/2 theta, then d theta. Okay, so we can now apply the calculator. Okay, so 2 pi so we have cosine, then 1/2, then alpha x. So we need to set the region mode since our solution is in the trigonometric function. So take note, our calculator is in region mode. Equals, no? So by the way, in your calculator, so the result would be equals to 0. So again, in this case, the length of curve will be never equal to 0 values. Okay, so since we have the symmetry on this, then we try this, no? Okay, so by the way, 2 pi is equivalent to 360. So that curve, or for example, if circle are enclosed, no, so that would be equals to 360. So if we take this pi, okay, then we take we indicate the axis of symmetry here is 2, no? So we have times 2 here. So that would be equals to 4. Okay. So therefore, our a's here, that would be equals to 4a. Our final answer.